Okay, so implicit differentiation. If y is equal to 4x squared y to the power 5, we want to find differentiate with respect to x. Okay, so the question says derive with respect to x. So dy dx for this, firstly, has a y value in there, right? Which is a little bit tricky. If I calculate if I derive with respect to x, technically what I'm doing is I'm actually saying d dx, which means derive with respect to x, of 4x squared y 5, and I can use the product rule. So that's going to become u, right, which is going to be that, and this is going to be v. So I'm going to end up with u times u dash, no, sorry, u dash multiplied u times the derivative of v. So I'm just like uv dash plus u dash v, basically. Now, if I derive this with respect to x, it's going to become 8x. But if I derive this with respect to x, I can't, because it's y. So I just rewrite it as is. And when I substitute that in here, u is going to become 4x squared. V dash is going to become that whole expression d dx y to the power 5. U dash will become 8x. V is y to the power 5. Exactly. So I end up deriving this function and I end up with a derivative in the solution of the answer. And that's the part where we now have to now get rid of. But now, because I'm deriving this with respect to x, I can rewrite it, right? And try and derive it to get it to become y to the power 4 multiplied by 5 using the power rule. So basically, by deriving y with respect to x, right? Whenever I do that, I use the power rule, I get 5y to the power 4, but right next to it, I write dy dx every single time. And why do I do that? Because basically that is exactly the same as that there. Dy dx will cancel out with this component over here. So I've derived the first part here. This over here, you can see, is the power rule on y, which means this expression is actually dy, dy, right? And the reason I multiplied by dy dx, because inevitably I've actually calculated d dx. So if y to the power 5 gets derived with respect to x, right, then technically we want to find d dx of it. So what we do is we do the normal power rule on the y, where we take 5y to the power 4, but then we multiply it by dy dx afterwards. And the main reason we do this is because what we're seeing over here is this is deriving it with respect to y. So that's what that is. And you can see that will take you back to d dx, because that will cancel out. So the formula we're actually using here is d dx can be rewritten as d dy times dy dx. And so we calculate d dy and multiply it by dy dx. So this part over here, where we're now going to take that and derive it, we're going to end up deriving this with respect to y. It's going to become 5 times 4, which is, so we get 4x squared multiplied by 5y to the power 4 times dy dx. basically. That whole component over there becomes that, plus 8x y to the power 5. And that would be the final answer there. We can just need to know the 5 and the 4 to become 20. X squared y to the power 4 dy dx plus 8x y to the power 5. And now we derive it fully with respect to x. Okay, let's have a look at another example. Let's suppose I've got y is equal to, or let's say I'm given the expression x cubed plus 5xy, and I want to find what is d dx of this expression, right? So when I derive this, I can derive each one separately. So d dx, x cubed plus d dx of 5xy, and here I've got a product rule coming up here. This is going to become 3x squared, 4x. And making this u, making this v, I get u dash v plus u v dash. That's going to be, the derivative of that is, let's quickly calculate, u dash is 5. The derivative of y with respect to x, remember, is 1 times dy dx. Yeah? So, because we're deriving with respect to x, y. So that will be v dash, so u dash will be 5 times v, which is y, plus u, which is going to be 5x, and v dash will be dy dx, like that. Okay. Now, when I write that back in here, I'm going to have 5y plus 5x dy dx, and I'm done. Wait. Alright. So whenever I derive y with respect to x, I add that component in there. When I've derived y, you can see from there becomes 1. Okay, implicit differentiation. Let's have a look at the next example of here. Let's try the next one now. So if I've got x cubed plus y cubed equals 4xy, and I want to find out what is dy dx equal to. The first thing is, if I calculate the derivative with respect to x of the whole function, each one separately, I'm going to end up with product rule here, where u equals 4x, so u dash equals 4. V equals y, and here v dash is equal to 1 times dy dx, because we can't derive y with respect to x, right? So d dy of y squared is equal to 2y. That's all good. But d dx of y squared means that we have to write 2y times dy dx, because we have to introduce the component that's going to cancel out to get that, which is actually d dy. In other words, to calculate this, we have to actually go d dy times dy dx first, to cancel it out to get that here. And so that component becomes 2y, dy dx. And so we have to write that afterwards. Okay? So over here, we do exactly that. We're saying that we're going to have d dy times dy dx, so that the y's will cancel out. this is 1 times dy dx, which is going to be b dash for that. Okay. Deriving this with respect to x cubed becomes 3x squared. Deriving this as well, y cubed, we do exactly that we're going to go. 3y squared multiplied by dy dx. Okay. And that's going to be equal to the product rule, which is going to be u dash. So here we get u dash v plus u dash 4 multiplied by y plus u, which is 4x multiplied by dy dx. That will be 4y plus 4x dy dx. Remember, u is 4x, v dash is dy dx, u dash is 4, and v is y. Okay. I've now brought everything into single file. I need to find dy dx. If I get these two alone now, I'm done. So now I'm going to solve an equation for dy dx and make it the subject of the formula. So I'm going to bring everything to the right hand side. I'm going to go 3y squared and bring the dy dx terms to the left hand side. We're going to end up with 4y minus 3x squared. And now I'm going to factorize this out. So we've got 3y squared minus 4x. That's equal to 4y minus 3x squared. And then I'm going to divide this at the bottom, getting me dy dx equals to 4y minus 3x squared over 3y squared minus 4x. Alright, I'll give you a second to just digest it. So that's my final answer there. And I've now found derivative. That would be it.